Look, good morning to all of you, dear colleagues from ISMA, CERN, and CLRS. Welcome to this morning's online training session, which is an overview about EU project management. To put this in, hopefully, some kind of context. Okay, I'll do that. To put this in some kind of context, so there's 3 training modules that I'll be giving, one each month, February, March, and April. This first one is an overview of EU project management. It's at a relatively, how should I say, abstract level, where I'll go in to talk about different phases of sort of EU projects. But when I do later training sessions, module 2 and module 3, they'll be a lot more specific, very practical, sort of oriented. So in module 2, I'll be talking about 2 particular phases: initiation phase and planning phase. And really the planning phase is very much about writing proposals. So during that training, I'll be giving a lot of very practical examples from proposals that I've been involved in writing. I'll be showing you lots of examples of figures, texts, tables that, for those of you who get involved in proposal writing, will be hopefully of use to you. Module 3 is about the execution phase, control phase, closing phase. And again, it'll be very, very practically oriented. It'll be very much focused on how do you go about implementing Horizon Europe projects, practical things about doing action item lists, reporting to the Commission and grant amendments and things of this sort of nature. Okay, but anyway, with today, as I say, it's a little bit slightly abstract to some extent. With today's agenda, I'm going to go through these 8 different things. So very, very briefly, I'm going to talk about the basics of EU research funding schemes. I'll then talk about, yes, this thing called project life cycle. I'll give an overview. And in essence, with the project life cycle, I'm saying there are the following phases: initiation phase, planning phase, execution phase / control phase, closing phase. And when I go through each of those, I will try to make it a little bit less abstract, a bit more tangible by giving a fictitious case study. So hopefully it will be a bit easier for people to relate to. And then very briefly at the end, I'm going to say a few words about project management methodologies. And lastly, because the preparing proposals, implementing projects is all about involving people. So I'm just going to remind ourselves what are the key roles and responsibilities of people in project teams. And then, although it's not shown on this slide, at the very end, I will describe a homework. It's not obligatory. You don't have to do it. But for those of you who perhaps want to sort of find it easier to learn things by doing something practical, it could be a worthwhile homework exercise for you to do. So first of all, yeah, basics of EU funding schemes. So to start with, this figure I'm showing here, hopefully many of you have already seen it many times before. This gives a very high-level view of the Horizon Europe funding program. So this is the main program from the EU. It runs for a period from 2021 to 2027. It has a massive budget of 95.5 billion euros. This Horizon Europe is also sometimes referred to as a framework program, and it's the 9th one that we had. The very, very first framework program from the EU. I believe it started in something like 1984. And each of these framework programs run for about a duration of about 7 years. Anyhow, with the current one that we're right in the middle of, as you'll see from the figure, it has this structure of these three pillars. Pillar one, excellent science. Pillar two, global challenges. Pillar three, innovative Europe. And then running at the bottom horizontally, you have this thing where it says widening participation and strengthening the European research area. I'm not going to talk at length about each of these different pillars, but maybe just to pick one or two things. I think for some of you, you may very well be aware of Marie Skłodowska-Curie actions that come under Pillar 1, Excellent Science. That's within that scheme, there is funding for what are called postdoctoral fellowships. There's also funding for what are called doctoral networks. Other parts of Horizon Europe, if we go to Pillar 3, European Innovation Council, within there's a scheme called Pathfinder Open that funds sort of very advanced blue sky projects. I know that's an area where certainly CERN has been involved in projects, and in fact where there's an interest within the TWISMA project to prepare a proposal. And then running on the bottom, this widening participation. This part of the program is particularly interesting for ISMA and institutions in Ukraine and say Central and Eastern Europe. It's very much about capacity building for universities and research institutions in those countries. And indeed, in fact, the TWISMA project, which we're all here for, this has been funded under the widening scheme. So, my next slide. So again, I'm going to do very, very briefly. Other sort of classic EU funding schemes, I'm sure many of you will have heard of Erasmus Plus. There are different key actions, but perhaps the one that many of you have heard of is student mobility. Perhaps some of you have already had the opportunity to spend, say, a semester going to another university elsewhere in Europe, and that's been funded through Erasmus. But as you see from this figure, there's other actions. It's not just about student mobility. Other funding schemes, this concerns less CERN and CNRS, but potentially for ISMA in Ukraine. There are these European funding schemes for regional development. This figure gives a very high level view. Often these funding schemes encourage collaboration and cooperation between countries, the regions bordering between different countries. Now, yes, it might not seem like an obvious area to fund research, but at times you might be surprised. Sometimes there are schemes which are encouraging sort of innovative projects. And well, look, I'm doing this at a very superficial level, but what I would perhaps like to encourage you to do is, if you really want to go, I mean, there's an incredible number of EU funding schemes out there. And I've literally stepped through just a few very, very superficially. But if you want this, like a sort of Bible, where can I find information about many other schemes? This is what I would encourage you to go and look at. So there's this publication, EU Learning. The QR code will take you to the PDF. Otherwise, there's also the web link here. But if you download that, it's a huge document, several hundred pages. You can do a keyword search, perhaps on particular terms that may be of interest to you, and maybe you'll find other sources of funding schemes. But in summary, what I'm trying to say is, look, there's clearly loads of EU funding schemes out there. But if you're going to be involved in any kind of EU funded project, of course, there's going to be project management involved. Now, why is project management important? I mean, of course, there's various reasons, and these are just slides that I'm highlighting here. So amongst the reasons why it's important to do a good job in project management, funding utilization. Efficient project management ensures that the funding obtained from EU schemes is used effectively and responsibly, aligning with the proposed budget, reducing wastage of resources. It's also important from the point of view of compliance. Project management helps in ensuring compliance with the rules and regulations set by the EU for these funding schemes, thus avoiding potential legal issues. Time management, proper project management allows for better time management, ensuring that research activities and milestones are completed within the given timelines. Risk management, it helps to be able to identify, assess, and manage potential risks that may affect the research project's progress or outcomes, thus reducing the likelihood of failure. And last but by no means least, quality control. Project management practices can help ensure that the research meets the required quality standards and delivers valuable and valid results. So we move now on to talk about project life cycle. So in this rather basic, crude sort of arrow figure I've got here, what I'm trying to illustrate is the different phases of a project. Now, it might seem, and obviously time, the idea of time is the sort of x-axis running along the bottom, going from left to right. Now, it might seem a little bit pedantic what I'm going to say now, but at the same time, it might give a bit of reassurance. What you notice with this figure is when you step from one phase to another, say from initiation to planning, I haven't got like a straight line. I have this sort of hatched arrow. And what I'm basically trying to convey there is the idea that, look, when you go from one phase to another, it's not like you, from one day to the next, you step from one phase to the following one. No, in fact, the reality is a lot of these phases actually merge into each other. There'll be tasks from one phase which are also relevant to the next phase, or you're finding that before you completed the initiation phase, you're already having to start doing activities in the planning phase. This sort of blurring is totally normal, and it's not something to worry about. Being able to juggle and do things in parallel is just part of the whole sort of process. So a few more words about these different phases. So look, the initiation phase. In broad terms, we can say this is the stage where a project idea is formalized. So in the context of EU funding schemes, this often involves identifying a research question that aligns with the priorities of the specific scheme. It also involves putting together a project team and creating an initial project plan, including objectives, potential impacts, and an overview of work packages. The planning phase, this involves detailing the steps required to achieve the project goals. In an EU research funding context, this phase is crucial to prepare a detailed proposal for submission. And I would add to that, in essence, the planning phase is very much about the writing of the proposal. That's where you capture so much. Your proposal is essentially a plan of action. Then these next phases, execution phase and control phase, which sort of run in parallel. So once funding is secured, the project enters the concurrent execution phase and control phase, which involves carrying out the research activities as planned. This includes regular reporting to the EU funding body as per the scheme's requirements. And then we have the closing phase. This phase involves finalizing all activities, completing documentation, and disseminating results. In the context of EU-funded research, this often requires a final management report or evaluation to the funding body, demonstrating the achievements and impact of the project. So let's now step into the initiation phase and discuss a bit more in detail what that's really about, and also try to illustrate it through a simple kind of case study. So the initiation phase. So this involves the determination of the project's goals and feasibility. So first and foremost, we need to define the research question. So let's imagine an example, a project in the field of scintillation materials for medical imaging and radiation detection. A goal is likely to be the development of some innovative synthesis techniques to improve the light yield, radiation hardness, and cost efficiency of some sort of next generation scintillation materials. Alignment with EU priorities. So one of the key goals of any EU-funded project is alignment with EU priorities. For instance, a project under Horizon Europe scheme would need to align with the key strategic orientations, such as promoting open innovation, addressing global challenges, or strengthening the European research area. And I would add to that, and this will be something we'll cover in Module 2, all the details, of course, are contained in what are called work programs, and you have what's called the call text. In those call texts, there's a particular structure, the way that the text is presented, and it'll be things like the section on expected outcomes and the section on scope, which you'll have to read very, very closely and make sure as best as possible your proposal aligns with those. That's the, in essence, the EU priorities. But other things we'll also need to think about, assessment of technical feasibility. So for our supposed project related to scintillation materials, one should assess the current state of the art in material performance and production technologies. We should do some sort of assessment of economic feasibility. So one needs to sort of analyze the potential cost of the project you're trying to put together. What are the funding sources? How much does the EU say they're prepared to fund the project? But also, if you're developing some kind of new technology, where's the evidence that there's a potential market demand, there's a potential market viability? And then lastly, in this area about feasibility, of course, we need to think about time feasibility. So, for a project, relating to scintillating materials, what's the likely timeline for developing this new material, this new technology? What might be potential risks? Who could be your potential team? And depending on the duration you think you need for the project, is that permitted by the call from the EU? So oftentimes the research projects, they're of sort of 3 to 4 years in duration. Other very important things to consider in this initiation phase. It's about identifying project stakeholders and understanding their interests. So in terms of stakeholders, we can broadly speak identify potentially the following. Certainly in the context of sort of projects relating to development of scintillating materials and, say, production technologies for scintillating materials. So first and foremost, we need project team members. So these are likely to be researchers, scientists, technical staff. Their interests, well, they'll be normally very interested in the successful completion of the project, but naturally they'll also be wanting to try to advance their careers and probably contribute in some shape or form to this field of study. Next, we can think about the funding body. So if we're talking Horizon Europe, there'll be the European Commission. Their interests would be in ensuring that the project aligns with the EU strategic priorities, that the project's carried out as planned and leads to impactful results in terms of, say, societal impact, economic impacts, healthcare impact, and so forth. Partner organizations. So these will be your other consortium partners. Typically, these projects are implemented by consortia. So that'll be organizations such as other universities, research institutions, companies. Their interests will include things like the generation of new knowledge, technology transfer, enhancement of reputation, financial benefits. Another stakeholder, perhaps one we don't think of so readily, but still important, regulatory bodies. So if your project involves activities that require regulatory approval, perhaps, for example, if you're developing some kind of new production technology for scintillating materials, maybe one of the specific requirements is that this technology needs to comply with certain environmental ensuring environmental sustainability. So there may be an aspect of ensuring that this new production technology meets the relevant regulations. Other stakeholders, obvious ones, end users or beneficiaries. So these could be, who knows, organizations or companies from the medical imaging industry, high energy physics, radiation detection and security, industrial and environmental monitoring, and of course, manufacturers of scintillating materials. They'll clearly be interested in the successful development and implementation of the project's results. And then finally, society at large. So especially for, say, projects that deal with societal challenges or public goods like climate change, public health, we need to think about society at large as being a stakeholder. And their interests, of course, will be in societal well-being, economic growth, and environmental sustainability. Still in this area of initiation phase. So now I want to talk a bit about something called a project charter, or what some people would also refer to as being an abstract. So if you're at this very initial stage and you're trying to get a concept, a proposal concept off the ground, and you're probably going to be involving unique consortium partners, it's very helpful if someone can produce a project charter or a project abstract. Essentially a document that's maybe 1 or 2 sides of A4, and it's something that can be shared with potential partners for the project proposal to capture their interests, to act as initial talking points, and so forth. So in this project charter, the things you'll want to sort of capture in it will be the scope of your project, the objectives, the stakeholders, and key deliverables. To make that hopefully a little bit more tangible, I'm using this case study. Let's imagine we're trying to do a proposal around the development of some sort of scintillation material production technology. So I'm calling it this project proposal simply innovative production technology for next-gen scintillating materials. In my project chart, as well as mentioning that, maybe under project objectives, I would list things like, well, look, our aim is to develop this novel production technology for high-performance scintillating materials. We want to enhance material efficiency, light yield, radiation hardness for certain advanced detection applications. We wish to, as also in our objectives, is to reduce manufacturing costs and environmental impact through the development and implementation of some sustainable production methods. Who do we see as being the key stakeholders? Project team, of course, European Commission, because we're hopefully applying to Horizon Europe, partner universities and research centers, but of course also some industrial partners. What do we think at this early stage will be our expected deliverables? It'll be things like, well, by the end of the project, we hope to optimize the production process for these new scintillating materials. We hope to create some prototype scintillators with superior performance metrics. Hopefully, we've generated some foreground knowledge that we've felt was worth patenting. And who knows, maybe there's even some sort of agreements have been signed for technology transfer with some production companies. And certainly during the project, before the project is completed, we hope to have done some kind of pilot scale production demonstration. What might be a preliminary timeline? Very, very simple, superficial at this stage because it's just initiation. Well, we're sort of saying, well, we think we need 4 years. By month 6, hopefully we've sorted out the optimal way to do the synthesis. By month 18, we've validated some sort of prototype. Month 30, pilot production has been hopefully successfully demonstrated. Month 42, we've got some industrial agreements in place. And month 48, at the very end, the 4-year project, we've done some final reporting and dissemination. So, but also, so we've done ourselves a nice project charter. This has helped to hopefully stimulate interest with a critical mass of consortium partners. But at the same time, we're thinking to ourselves, well, we need to think about the initial project team. So again, to illustrate this, using our simple case study on the scintillation material production. So who might they be? Well, the principal investigator, she or he, they need to be a senior researcher in material science or applied physics. Their responsibility will be to lead the scientific direction and oversee research progress. But clearly, there's going to need to be there's a need for other research specialists. These will be likely to be material scientists, chemical engineers, physicists, data analysis, not mentioned here, but people with some production experience, industrial partners, manufacturing firms, possibly photonics and imaging companies. We'll need a person who's going to coordinate the outreach activities. This will be somebody who can engage with academic, industrial, and public stakeholders, organize workshops, publications, EU-funded dissemination activities, as well as manage open access knowledge sharing and public engagement. And then last, but certainly by no means least, because we're talking about project management here, there'll need to be a project manager, and that person, they'll need to oversee project timelines, deliverables, administrative tasks, coordinate with the funding agency, manage risks, budget allocation, inter-team communication, and support IP protection and collaboration agreements. Also within the initiation phase, we're thinking about the funding, and well, with amongst resources, there's clearly funding, but it's also about people and equipment. If we look again to my simple case study on scintillating material production, so for funding, we're saying we're going to go for an EU grant. First thought is, well, within Horizon Europe, maybe under the European Research Council, there's some opportunities there. Maybe under EIC, European Innovation Council, Pathfinder, maybe other schemes, even who knows, perhaps through the doctoral network scheme under Marie Skłodowska-Curie actions. Anyway, we're looking for this funding, whichever source we get it from. We're going to use that to cover the research equipment and personnel costs. But besides grant funding, maybe there's potential even also for co-funding from industrial partners for technology transfer and pilot production, or at least contributions in kind. Also, who knows, maybe different partners have access to national funding sources or research infrastructure, and that can also be a resource to consider. Personnel, I won't read through this because we already covered it in the previous slides. But skipping on to equipment, what might we be thinking about? Probably it's stuff like advanced material synthesis tools, characterization instrumentation, radiation testing facilities, prototyping and manufacturing equipment. And then facilities, Ideally, the university and research institutes have labs we can have access to. If not them, hopefully industrial partners have some sort of clean room facilities we can access. And yes, we'll need somewhere where we can do pilot scale production and real world application testing, and hopefully that will be at one of the industrial partners involved in the project. Going more into the definition of project deliverables. So I'm jumping straight again to the case study. We sort of gave these titles already for these deliverables earlier, a few slides earlier, but let's expand a little bit upon them. So optimized production process for next gen synthetic materials. So here we're really saying the deliverable will be development of cost-effective, scalable, sustainable manufacturing method that enhances material efficiency and performance. Prototype scintillators with superior performance metrics. So here we're saying the idea is to fabricate these advanced scintillating materials with improved light yield, radiation hardness, and faster response times for high precision detection applications. Intellectual property and tech transfer agreements. So we want to protect any novel material compositions, production methods that we may have developed through patents. We wish to facilitate commercialization via licensing and industrial partnerships. Pilot scale production demonstration. So we want to validate this optimized manufacturing process in an industrial setting to ensure feasibility, reproducibility, and readiness for market deployment. Last slide in this initiation phase. So already in this initiation phase, it's good to think about what are likely to be possible challenges, in other words, possible risks. What could go wrong? I mean, and there'll be loads of things that potentially go wrong. At the same time as with trying to identify early on what these risks, challenges are, we're going to need to push ourselves and think about what are mitigation measures to help tackle those problems if they arise. So in the context of our case study, broadly speaking, we can see there being 4 different types of risks. Starting with technical risks. So what could go wrong? What could be a challenge? Well, certainly the optimization of material performance. We say we want to get the adequate light yield, radiation hardness, and stability, but we may not achieve those, at least to begin with. So what are the concrete ways we could try to tackle those issues as and when, if they arise? Other technical issues, scaling up production without quality loss. This is often very, very challenging. What kind of experience, what kind of know-how can we draw upon to mitigate this problem if it arises? Ensuring compatibility with existing detection systems could also be a technical risk, and we need to figure out ways to address that. On the financial resource side, we might encounter budget constraints and high equipment costs. Regulatory and compliance risks. It may be a challenge for us to meet environmental safety regulations. And this 4th category of risk, collaboration and management risks. The difficulty of coordinating interdisciplinary teams that are spread geographically, ensuring that there's good communication between them and that they really are collaborating together. That could be a challenge. But also it could be a challenge with technology transfer, actually establishing an agreement, especially when you have these sort of consortia doing projects, getting to agreements on how to share the intellectual property, the foreground knowledge between the partners, and how to go about actually commercializing that and having technology transfer. That can be extremely difficult because different organizations in different countries have different requirements when it comes to licensing or setting up intellectual property. So that's enough at this stage about initiation phase. Let's now move on to the planning phase, which I mentioned earlier on deals a lot with sort of proposal writing. So one of the first things you'll be sort of really thinking about in the planning phase is about developing a detailed project plan. Already in the initiation phase, we kind of sketched out what might be a rough timing over 4 years. But now we need to get more down to detail. So this will be in the context of our case study. We need to think about the work breakdown structure. So often with these EU projects, you'll hear people talking about work packages. Work packages just are a grouping of tasks that have some kind of commonality among them. And in the context of a project dealing with development of scintillation materials, especially one where it's about production and some sort of commercialization, broadly speaking, the work packages might look like this. There might be one work package 1, which is dealing with material synthesis, work package 2, which is more about the characterization and testing, work package 3, we're doing some prototype development, work package 4, where it's the pilot production, and then work packages 5 and 6, where it's sort of about the commercialization, dissemination, and project management. Since we're now at the detailed project planning stage, we'll need to go drill down more into the resource allocation, the personnel, and the funding. So we've already, in fact, spoken quite a bit about personnel, so I won't say any more, but the details of the facilities. Where's what going to be done by what partner? That sort of thing needs to be clarified. Likewise with the equipment, who will be doing what, or who has what access to what facilities, and who will be doing what. The timeline. At this point, we're trying to describe it more explicitly. Maybe it will look something like this. So maybe we're saying from start of the project to month 6, we'll be doing project initiation, team formation, and requirements analysis. Month 6 to month 18, we're saying we're going to do the R&D of the innovative production techniques. Month 18 to month 30, we're going to say we'll do the prototype fabrication and performance validation. By month 30 to month 42, we're at the point where we're doing the pilot scale production and real world application testing. And then in the last sort of 6 months of the project will be final evaluation, dissemination of results, and commercialization strategy. And with this detailed project plan, we'll also need to specify what are the milestones. So milestones are, say, key points in the project, which, how to say, these are key points in the project which need to be completed in order to sort of progress through the project. With all EU-funded projects, it's important to have milestones spread across the whole of your project, not all just stacked up at the end, but also early on. So in the context of our case study, this might be, we may be saying, look, by month 6, this is when we aim to have the optimized synthesis. We aim to have this clearly documented and finalized. By month 18, we're saying we will have a validated prototype. For the European Commission, when we're running the project, the aim is to have this prototype, film, photographs, whatever, which we can show them. Month 30, that's when the pilot production should be successfully completed, or at least that's our aim. And yeah, month 42, industry agreements, month 48, final report and dissemination. In this planning phase, this is a point, at least, where we need to go into more detail about the budgeting and scheduling plans. So looking to to our case study. On the budgeting side, these percentage figures, these are not exact. These are just indicative, and it varies from case to case. But possibly your budget, you might be saying, well, we need roughly 40% of the budget for personnel. I suspect in many cases, in many projects, in fact, this percentage is probably higher. But anyway, this is just for this example. With equipment, for this example, we're saying we need 25%, perhaps because we feel we need to invest and purchase some new tools, new characterization equipment. And then facilities and operations, and perhaps we're saying 15% because we know there's going to be significant costs for perhaps we need to hire labs, or we need to buy certain research consumables, production consumables, and so forth. Dissemination and intellectual property, as a general rule, this should never really exceed about 10%, but 7, 8, whatever percent, something like this usually goes down pretty well. And this is funding that you'll use to, say, cover your costs to go to conferences, to present research results, the cost of publishing in research journals, and say costs potentially for filing patents. And then, yeah, it's best, lastly, contingency. It's best to have a bit of a safety margin. Yeah, so written here, contingency 10%. In actual fact, this sort of 10% will be spread across in your budget. In your proposal, you won't have like 10% contingency. It'll be more a case of where if your personnel budget was, you think you definitely need 40%. In fact, you'd be indicating 44% because you include this 10% of contingency. Scheduling plan, yeah, this is in essence a kind of repetition of the timing that we talked about in the previous slide. In the planning phase, another very key important thing to consider is about quality metrics and your objectives. So the funding body, the EU, they need to have, if you get your project, they're going to need to have a way to assess, are you being successful? Are you implementing the project as you said you would? And this is where quality metrics, or more commonly, people talk about key performance indicators, come into play. In the context of our case study, maybe our quality metrics, perhaps they would look something like this. The numbers here are not definitive, it's just there as an example. But if we're talking about material performance, maybe we'd be saying with our project, look, our aim with the light yield is to get above 40,000 photons per mega electron volts. Maybe we'd be saying decay time needs to be less than 100 nanoseconds. Maybe we'd be saying, look, for our radiation hardness, we need to maintain 95% or better after after such an exposure. I stress those numbers are not definitive; they're just there as an example. On the production side, our efficiency, maybe we'd be saying, look, we're trying to get a yield rate above 90%. Maybe we'd be saying our cost reduction, we want to get more than 20% lower production costs compared to existing methods. For the prototype validation, we might be setting ourselves the following targets. Detection efficiency better than 98%, energy resolution below 10%. On the area of reproducibility, batch variation, we'd be perhaps saying, look, we want to get less than 5% deviation in optical and physical properties. Regulatory compliance, we aim to adhere to EU safety, environmental and quality regulations. This thing called technology readiness, I don't really have the time here and now to go into lots of detail about it. I'll be talking about it in the Module 2 training, other than to say it's a sort of categorization for, it's a numbering system for sort of describing how, at what stage one is in the technology development process. And as the number gets higher, the closer you are to market. Anyway, for this particular case study, we might be saying that by the end of the project, we aim to reach technology readiness level between 5 to 7. And then lastly, dissemination and impact, which the Commission places lots of importance on. Maybe we'd be saying, look, we aim to publish at least 5 peer-reviewed journals, papers by the end of the project. We aim to have a certain number of patents, at least 2. Industry adoption, maybe we aim to have at least 2 tech transfer agreements in place by the time the project ends. So we've talked about initiation phase, we've talked about planning phase. Let's assume we've done this fantastic proposal and we've been very fortunate, it's been selected for funding, and now we're running a project. So now we need to think about execution and control. So things to consider in the execution side. So we need to deploy our resources. We need to start executing the project plan. In the context of our case study, personnel deployment, so maybe we're saying, look, between years 1 to 5, our aim is to have 5 researchers, 2 technicians and 1 project manager working on the project. They need to be contracted, employed, they need to have a clear understanding of what their roles and responsibilities are. But later in the project, by years 3 and 4, maybe the aim is to expand our team. By that stage, maybe there'll be some additional researchers, technicians, and also commercialization experts. And likewise, they need to be contracted. They need to have a clear understanding of their roles and responsibilities. On the equipment side, this may be the rough sort of, well, less rough plan of deployment for that equipment. These dates are indicative, but whatever the dates are, one needs to think in advance. I mean, if one is hoping by month 6 that there's installation and calibration and characterization instruments, believe you me, you probably need to be thinking already, even before the project starts, about the booking or the ordering of that equipment to make sure it's available for deployment from month 6. Looking further down, facility utilization. So we're saying here, look, yeah, between months 0 and month 24, we need to have access to these university labs for material synthesis, prototyping, and early testing. Month 24 to month 48, industry partner sites need to be available for the pilot scale production and real world validation. But as already mentioned with equipment allocation, you always need to think in advance. You can't expect to sort of arrive at month 24 and only at that point start asking about the availability of these industrial partner sites. Almost certainly these industrial partners will need, I would imagine, at least a 6 months head up beforehand to make sure that their facilities are available, and quite possibly even more than 6 months, maybe the best part of a year in advance. So execution phase. We need to think also about the management of teams and their tasks. Looking straight to the case study. So task allocation. We've broadly speaking got these teams. So our materials team, they need to know what they're going to be synthesizing and optimizing in terms of scintillating materials. The characterization team, they need to be tasked and have a clear understanding of the performance testing they need to do and have access to the relevant facilities and equipment. The engineering team, likewise, are going to be doing prototype fabrication scalability assessment. Industry partners, pilot scale production, commercialization strategy. And the project management team needs to be obviously recruited and tasked with coordination, reporting, and risk management. On the sort of performance monitoring side, so we've defined these key performance indicators, these quality metrics. Somehow we need to make sure that these are regularly being captured and this information is available to the relevant team members. Midterm audits. So typically with the Horizon Europe projects, there is midterm reporting and final reporting to be made to the European Commission. And they need to be planned for in advance for those reviews. So there needs to be a clear understanding by the project management team beforehand of what that reporting requires, and that they in turn are communicating with the various teams to get the necessary information in order to do the reporting for those audits. When you're dealing with people and teams, they're especially spread across different countries, different organizations, there is a great potential for there being conflicts or misunderstandings. How do you go about trying to deal with them? Well, it's very important right from the start, the offset in the project, and this is typically sort of captured in something called a consortium agreement. But it's and explained, say, during the kickoff meeting of the project, but it's really important that there are clear communication channels. So these projects have a sort of hierarchy, team members, managers, coordinators, and so forth. They should be communicating on a regular basis. In an ideal world, this will be through weekly team meetings. So any issues that maybe cropping up in the project, they get tracked and identified early on, thus hopefully avoiding any kind of escalation. But in the case where there is conflict, things are escalating, then there needs to be some kind of protocol in place. And again, this is where what's called the consortium agreement, this is where this is sort of formally captured. So there needs to be a formal process. It needs to be involve, say, rapid intervention by the project manager to tackle. And assuming there is a conflict which is difficult to resolve, there needs to be some sort of mediation process. So maybe this would involve efforts to resolve the conflict through an independent advisor. With that said, with conflict, hopefully you're doing projects where you have a lot of experience already with the consortium partners, where there's a lot of personal good relations. And so most of the time, conflicts don't really get a chance to escalate to that extreme degree where you actually need some independent advisor. Lastly, on execution, the implementation of approved changes. So even with the best will in the world, challenges and risks crop up during the project. And although you have what appears to be this perfect plan captured in your proposal, things go slightly wrong, or unforeseen risks crop up, and this leads to some kind of delays or the need to make changes. In the context of our case study, what are the classic kind of things that maybe change and therefore require some sort of formal approval? Well, firstly, methodology changes, perhaps the optimization of the synthesis process. Maybe there's a need to shift to a more cost-effective method. Maybe there's a need to enhance the testing protocols. For example, maybe you need to consider introducing some sort of AI-driven data analysis for faster material characterization. Those are just two examples. Facility changes. Maybe the clean room facilities that you originally thought you were going to use, maybe they're going to be upgraded, or they're simply not up to the required standard that you need. maybe you need additional testing facilities at partner manufacturing plants. Another classic change with project teams. Key staff members leave and need to be replaced. That's probably one of the most common changes that I see in projects. And then schedule changes. So you have some initial timing, some issue crops up, and it leads to delay. So often there's a need to say make a formal request to the European Commission to extend the project. This is not a trivial thing normally to do. It is feasible, but you need, in order to get authorization approval from the Commission, you need to make a strong case, strong justification about how this risk is threatening the non-achievement of an important milestone. And that's and if you are requesting extension, you have to bear in mind that normally at the very most, the Commission will only say grant maybe 6 months of extension. The only exception I've known in the last 20 years to that has been when we had COVID, and then the Commission was allowing extensions of up to 12 months. So control phase, which runs in parallel to execution. So as the name suggests, it's about the tracking, review, and regulation of project progress. With our case study, the things we might want to do is say have a project dashboard, some sort of easily accessible location where partners can see where we currently stand with regard to our KPIs. This might be in an action item list, or it might be on some sort of common drive. It could be information about where we are currently with the KPIs, where the consortium stands with regard to the milestones and progress on those. And in an ideal world, it will also give some sort of budget overview. I mean, written here, live monitoring expenditures versus planned costs. I think this is somewhat idealized. In my experience, usually the only time you get a budget overview is when you're doing the midterm and final reporting to the Commission. Laboratory visits. So especially in the context of, say, the principal investigator and the project manager, it's really good if she or he is proactive, that they make laboratory visits. I mean, I've written here quarterly inspections. I think probably even more regular than that. It's good that they go out and check that there's compliance with necessary protocols and seeing progress, and perhaps more importantly, they're hearing from the foot soldiers, from the researchers, the scientists, what are the challenges, what are the issues they face. So they hear that really early on. Status reports. So yes, we have kind of status reports that need to be done formally to the Commission, but also it's good to have some sort of status reports for sort of internal consumption. So maybe these are done on a quarterly basis. You know, the work package leaders, potentially they summarize what their progress is, any issues, and so forth. EU compliance reports, yeah, the midterm and the final review of the project, the financial and technical information needs to be provided to the Commission. But also, let's not forget consortium meetings. Typically, these are every 6 months. These are also very good opportunities for sort of tracking, reviewing, and regulating the project progress for the project manager, project coordinator. So yeah, controlling is about somehow comparing actual performance with planned performance. What might be the things that one needs to bear in mind on this aspect? Well, in our context of our case study, we can think about timeline tracking, budget comparison, KPIs. So on the timeline, how are we doing with regard to our milestones? Are we on track to successfully pass them? Or do we need to do some kind of adaptation, updating of the work packages, the timing? Likewise, budget comparison. As mentioned in the previous slide, this is usually only done at sort of in practice at the midterm and at the end of the project. But at that midterm point, often you already see deviations between the actual cost that partners have booked versus what was actually budgeted and indicated in the proposal. And maybe that that sparks a discussion about the reallocation of budgets from one budget category, I don't know, personnel costs to travel, or perhaps there's excess budget in travel, but insufficient amount from personnel. So this kind of comparison and discussion needs to be take place. And then yes, KPIs, I think we've already mentioned those in previous slides, but there needs to be some monitoring of where you stand versus where you said you hoped to be. We move on to talk a bit about the closing phase. So in the closing phase, hopefully, we will be delivering our final product or service. So thinking of our case study, assuming everything aligns perfectly and we don't have any insurmountable challenges. So during the course of the project, well, hopefully we will have delivered this final prototype production process that meets our KPIs. We'll also be delivering technical and scientific documentation. So it'll be a final research report that summarizes the methodology, results, and impacts. We'll have information about the publications and patents that we said we were aiming to achieve. Project reporting and compliance, we will have done the final, the period 2 or the final period management report, technical reports. We'll have also submitted our final financial statements. On the dissemination and public engagement sites aspects, often with research projects, there's some kind of final conference where the main results of the projects are presented. We also need to think about open access data and outreach. So any data produced should be publicly accessible. Any papers that we've produced should be in open access journals, open access repositories. Since we're in the closing phase, at this point, we're also releasing project resources. So in the context of our case studies, we can think about human resources, physical resources, financial resources. So human resources, project team members can be reassigned, or their contracts are ended. Physical resources, the laboratory equipment, the manufacturing facilities we use, they all need to be returned to their original state or reassigned to other projects for other purposes. Financial resources, when we've done our final financial statements, possibly there's unspent project funds, in which case they need to be returned to the funding body. And lastly, in this closing phase, it's a good opportunity to document any lessons that we learned. In the interest of continuous improvement, and assuming you see yourself sort of doing project management over the medium to long term during the course of your research career, it's a good habit to sort of document what were the strengths and weaknesses that occurred during the course of your project. So for our case study, what might these be? What might be the things we want to sort of document to help ourselves improve? So on the technical insight side, material performance gaps, we might want to write about what were the deviations with respect to our expected light yield and stability, and what might be ways to improve upon that. Process optimization. We might want to document the best practices that we learned for scalable, cost-effective production. Testing and validation. We might want to record improvements that we observed in characterization and radiation testing, or the lack thereof. Our learnings from project management. Maybe we had to make timeline adjustments during the course of the project. Maybe now is a good time to sort of document what were the causes of those delays and what were successful ways to mitigate them. Budget efficiency. Were there any measures that we took that helped to save costs? Or were there, relative to our original foreseen budget, were there big changes? Did we overestimate the amount to allocate for travel or underestimate the amount for personnel? Are there things going forward that we can learn from that? Collaboration challenges. Did all the partners get on? Were we one big happy family? Were there any kind of conflicts that arose? Did they get satisfactorily resolved, or is there a way things could be done better? Risk management review. Did our original risk management plan, did it satisfactorily cover all the risks that we encountered, or were there some unexpected issues? Again, if there were, let's maybe document them and have good mitigation measures for future. So that's, I think, enough about the closing phase. Very, very briefly, I want to move on to say some words about project management methodologies. And I'm only going to talk about this very, very superficially. So look, broadly speaking, there are many different methods, many different approaches to management of any projects, be it EU-funded projects or IT or manufacturing or whatever. In the context of EU projects, these are arguably perhaps the three that you might encounter, and I would even go so far as to say most of the time it's probably the first and to some extent the second of these two methodologies. So these three I'm talking about. Waterfall methodology. So this is a very traditional project management methodology. It's rather linear and sequential. Each phase must be completed before the next one can begin, making it suitable for projects with clear, unchanging requirements and where tasks are dependent on each other, such as many research projects. PRINCE2, which is short for Projects in Controlled Environments. This is a process-based approach that provides a detailed roadmap for how the project should be managed and executed. It's widely used in the UK government and also in many other sectors and countries around the world. Agile methodology. So this is a methodology that's become very popular since 10 years or more. It's certainly widely used, has been widely used in sort of IT development. It's a methodology that's iterative and flexible, allowing for regular adjustments throughout the project. Although it's widely used in software development, it can also be applied to research projects, especially those involving complex tasks, rapid changes, or a high level of uncertainty. I would say with the Agile methodology, it's probably not a methodology that can be easily applied to the whole entirety of an EU project, but maybe for specific scientific tasks. Anyway, if you are getting very deeply involved in project management, I suggest you perhaps go away and investigate these methods. And certainly, what might be interesting for you to know is that there's professional certification that can be obtained for these different methods. If you do a Google search, type in something like PRINCE2 space professional certification, you can find details of organizations that give formal trainings on those and initial certifications for those. Very last thing to sort of touch upon, roles and responsibilities of project teams. So this has already been talked about on various other slides, but really just to sort of, it's almost like an avatar here to sort of say, it's rather banal, obvious to say, but the implementation of projects involves people. And they're perhaps paramount in our thinking when we're managing projects. And so just to sort of repeat to ourselves, who are these key roles? Well, it'll be project manager. I'm not necessarily in this order of priority by any means, but we need to think about the project manager, principal investigator, not mentioned before, but project administrator. So there is a lot of bureaucratic paperwork and the reporting to be done on these projects. It's good to have a person or persons who can help with those tasks, that can facilitate those. Speaking honestly with you, that's often my role in these projects. Research associates and assistants, we talked already about them. Stakeholder representatives, we talked to some extent about those. And certainly dissemination and communication officer. Earlier on, we talked about an outreach coordinator / dissemination communication officer. They're essentially kind of the same role. But these are the kind of the key roles, the key people you need to think about for your projects. So, looking at the time, an hour and best part of an hour and a quarter. So look, I hope I haven't bored you too much with my droning on talking through these slides, but assuming I still have some degree of your attention, my very last slide here is about a homework. Now, as said earlier on, it's not obligatory. You don't have to do this, but for those of you who want to do it, and you don't need to do this homework in order to be issued a certificate of project management from attending these 3 modules. But if, like myself, you're someone who finds it difficult to learn by just sort of passively seeing a presentation and slides, but that you feel you need to do something active, by all means do the following homework. So the homework is the following. So I basically want you to come up with your own kind of case study. It can be on any topic of science and technology. Choose a topic most relevant to you. Obviously, in the case study I've shown in these slides was a rather generalized one about sort of developing a production technology for some new advanced scintillating materials. Maybe you've got something very specific in mind in that area. Fine, go ahead and do that. Otherwise, maybe you're dealing with a very different field of science and technology. It's all good. Anyway, choose your topic, and then please describe the issues that will need to be considered in the initiation phase. So go back to my slides where I talk about the initiation phase, in particular, where I talk about project charter, initial project team, initial resources, and so on and so forth. And please describe those, elaborate those for your own case study. Altogether, this is perhaps a couple of pages of A4, or if you prefer to do it on PowerPoint, that's also good. Assuming you want to do the homework, please can you email it to me at the following email address, and please do so before the 14th of March, and I will then endeavour to review your homework and give you some supportive and critical feedback.